Hello guys, welcome to Spark Tech Academy. Today we will be going through electrical instrumentation and electrical measurement subject in competitive exams, especially as per the upcoming DISCOM exams of all over the state, and also for national exams like ISRO, DRDO, all electrical engineering exams. These questions will be very helpful to you. I will be solving the electrical measurement and instrumentation. This will be our part 1 actually. We will be going through some basic concepts as well as problems. Now first of all, what you will learn is the limiting error, which is actually asked in your exam. Many times it will be asked. So first of all, before studying that, we will be going through absolute static error. Absolute static error. What it will be? Absolute static error will be measured value minus true value. In some books it will be as if AM minus 80. It is measured value, it is true value of that instrument, and it will give you a static error. The error will be delta A, you can say. Now one more important thing is that you will come across some static correction type of things. This will be one question definitely asked in your exam. Static correction. What is static correction? Static correction is nothing but true value minus measured value. It will be 80 minus AM. It is delta C. It is a correction. Here you can say delta C will be minus of delta A, means correction is equal to minus of error. You can say. This is a very important concept because mostly in exams they will ask you to calculate static error, or you can also say it as absolute error, measured value minus true value. The formula is very simple. It is just they have given you the measured value of that instrument and true value, and accordingly you have to calculate this. And static correction is nothing but true value minus measured value. In many ways they will be giving you the 4 options. In that many times what happens is that when you subtract measured value minus true value, it will be positive value. In answer. This is one trick you should remember while selecting the answers from the MCQs. And so what static correction is always a negative value. Hence please take it also into consideration in MCQ while finding that answer or while selecting the appropriate option. Static correction is nothing but minus of this static error. Please note it down very carefully. Now we will be going through guaranteed accuracy error. Guarantee accuracy error, which is denoted at GAE. Now, how to calculate this error? In problems, they will be giving you the percentage accuracy, error accuracy of full scale reading of instrument, full scale reading of instrument. They will be giving you this, and already this will be given in your given problem, and accordingly you have to calculate the guarantee accuracy error. Now we will take one example. Let the ammeter range or ammeter range 0 to 25 ampere. This is the scale, means total scale. What is full scale reading in this case? Full scale reading will be the highest reading, or you can say the final range of that, final scale reading of that instrument. Now here the full scale reading will be, full scale reading will be in this problem 25 amperes, and they will be given some sort of percentage error accuracy, that is guaranteed accuracy error in percentage 1% of full scale. Now how you will calculate it? It is nothing but 1 divided by 100 into this 25. You will be getting as 1 by 4, you can say 0.25 amps. This is nothing but guaranteed accuracy error we have just found out. In same way, now what again one thing I want to tell you is that this is just the calculation of guarantee accuracy error. Now the next step is we have to calculate the limiting error. Now we will find out the absolute limiting error in upcoming example. I will keep this example as it is. Now again one thing is given in given, it is the measured current value, measured value of current. Suppose this measured value of current is of 2.5 amperes as given, 2.5 amperes as given, or for sake of simplicity take it as 5 ampere only, so that the calculation will become simple. Now what you will do is limiting error, limiting error is nothing but this GAE percentage, current accuracy error percentage, divided by measured value of given quantity. It may be current, it may be voltage, whatever it may be, into 100. This is percentage limiting error. Now only we have to substitute the calculated values, 0.25 amps divided by measured value is 5 ampere into 100. Now what will be 25 divided by 5? It will be 5%. Therefore percentage limiting error of given problem will be 5%. Please note it down very carefully because it will be very helpful to you as far as your exams are concerned. What will be given is that the scale will be given. The from scale you have to find the full scale reading. Full scale reading is nothing but the final maximum value of that scale that will be taken as full scale reading, the full scale. And scale is nothing but, you can say, if you want to remember the scale, scales are like this will be 0 and this will be the max value whatever it may be given. This max value will be nothing but full scale. In given problem you will calculate the full scale like that, and from full scale the GAE will be given, guarantee accuracy error. It will be in form of percentage of that full scale. That's why we have calculated 1% into full scale 25. It will be 0.25, and accordingly from that values only I have told you the measured value of current is also given, and accordingly just substituting the values in that limiting error formula you will get the limiting error. Note it down, it is a very important thing because it will be definitely asked in your exam. You can also try some sort of questions on it. Now again one thing is that we will calculate the span is difference between maximum value. It is nothing but difference between maximum value on scale minus minimum and minimum value on scale. If suppose minus 5 to 5 is given, in this case span will be maximum value 5 minus of this minus 5. The span will be 10. Let it be in volts, so the answer will be in volts. Now this is the span, or in either way you can say let V1 to V2. Now V2 will be max and V1 will be mean value, and accordingly the span will be V2 max minus V1. This is the definition of span of reading. Please note it down. Now again one type of problem will be asked in your exam regarding bridge balance equation. Means sometimes they will be telling us to calculate the unknown resistor. You can say the problem is such that it is R4 is equal to, we have to calculate the R4. In this case what will be given, they will be giving you the equation R4 is equal to R2 R3 divided by R1. This is given in your example. Now the values of R2 will be given. Value of R2 given is as 1000 plus minus 0.5 percentage. R1 will be given as, they have given us these values and accordingly we are calculating, and R3 is also be given. This is nothing but a bridge balance equation or Wheaton bridge. This will be a Wheaton bridge equation. Wheaton bridge balance equation. Now from these given values we will calculate the R4 as R4. First we will calculate the magnitudes of these. Magnitudes in sense 1000 into 844 divided by 100. You will get as 8420 ohms as per calculation. It is nothing but a magnitude, and what this is, these are nothing but the errors. When for multiplication of errors, this is very important, multiplication of errors. In that case what happens is DYEE R1 by R1 plus minus, you can say it as plus minus DYEE R2 by R1 R2, DYEE R2 by R2, and in the same way DYEE R3 by R3. Just what you will do is, you will just add all these things. You will be getting R4 by R4 in case of multiplication. These terms are nothing but change in R with respect to the same quantity, means change in R1 with respect to R1, change in R2 with respect to R2. These are nothing but errors. Just what we have to do, when multiplication is given in this form, we have to just add the errors. What the errors are? 0.5, 0.5, 0.5. It will be plus minus 1.5%. This will be DYEE R4 by R4. It is nothing but change in R4 by R4. Now the final answer will be R4 is equal to 8420 plus minus 1.5%. This is nothing but the final answer you will be getting, and from MCQ you will be selecting this. This is a very important thing because they try to confuse you in examination, because they will be giving you the error magnitude and also the error, and due to this what you will do, sometimes it may happen that you try to multiply these errors also, but actually from the fundamentals point of view, the multiplication of the errors will be given by this formula. Actually this is nothing but a simple formula. In that case what happens is magnitudes get multiplied and errors get added. I will write the trick: multiply magnitudes and add errors when multiplication is given in numerical. Please note it down. This is very important thing. Now again one important concept which I will be teaching you is range error problem. Now for range error, I will just give you one formula for range error actually, and then I will be teaching you what is range error with the help of range error is nothing but maximum value minus average value of that quantity Now in this case, what is given, please try to understand. Maximum value, you can also say maximum value as extreme value, because in many textbooks they have given extreme value. Now for example, the values are given as 1.20. This is a given problem, and accordingly we will be solving. These all problems are been asked in your examination, so I am taking this. These are the 5 values which will be given in terms of volts, as this is the measurement of voltage. Now first find out the maximum value from the given problem. The maximum value, if you look carefully, this is the maximum value. Then what you will do is, you will just note the max value first, 1103 volts. Now what you will do is, now you will add this 5, means you will first calculate the average reading. Average reading will be 110. All these readings will be added. And divided by number of readings, 5. This is nothing but a simple average formula. Addition of all readings, summation of all the readings divided by number of readings. Now you will get this value as, please try to calculate it. It will be some about 110.20. Now this will also be in volts. Now we will apply this formula, range error. The percentage range error will be plus minus modulus of maximum value minus 110.20 plus minus, you will get as 10 volts, let's say. This is range error. You can say. This is not percentage actually, this is only a range error we have calculated, it is not in percentage. So please note down this. Now again one problem we will be taking on error, limiting error, you can say. The practical problem actually, what they have given is, in DC motor input measured value is given. It is 2 kilowatt plus minus 4%, and loss is given as loss value is given as 200 plus minus 5 watts. It is in watts. Now what they have told us? They have told us to calculate limiting error in output power. We have to calculate. Now first of all, what we will do is, first we will calculate the plus minus 4% error in terms of input value. In input power, we will calculate as 4% is 4 divided by 100 into 2000 watts, means 2 kilowatt. You will be getting it as 80 watts. It is nothing but, you can write it as 2 kilowatt plus minus 80 watts. This is nothing but a input power. Now you should know one basic formula. What is output? Output is nothing but input minus losses. This is very